Hello everyone, my name is Tony Wen and my group member is David. Today we will going to talk about the 2.6 relative rates part 1. And it is about the relative rates. The definition of the relative rates is about real-life problems rarely involve just a single variable. Most are written in terms of multiple variables. Relative rate problems are real-life situations based on problems that change with respect to time. We can differentiate these problems implicitly.
Now we have a first question, the volume of a cone. The original equation of the volume of a cone is V equal to 1 over 3 pi square h. So to calculate the rate of change of the cone, we have the equation of dV over dx equal to 1 over 3 pi r squared and dh over dt plus h 2 over 3 pi r dr over dt. So we have dv over dt equal to 1 over 3 pi r squared dh over dt plus 1 over 3 pi rh dr dt. Yes, that's it. So our example in general gives the function y equal to x squared plus 3 and dx over dt equal to 2. When x equal to 1, find dy over dt when x equal to 1. Oh, so we have the original equation y equal to x squared plus 3 and d over dt y equal to d over dt x squared plus 3. So dy over dt equal to 2x dx dt because derivative. So dy over dt equal to 2 times 1 times 2. So we have dy over dt equal to 4. That's easy, right? Next, we have an example of inflation bomb. Air is being pumped into a spherical bomb at a rate of 4.5 cubic feet per minute. Find the rate of the change of the radius when the radius is 2 feet. So the original equation of the spherical volume is V equal to 4 over 3 pi times r cubed. So we have dv over dt equal to 4 pi r squared dr over dt. And we know the r radius is 2 feet, so 4.5 equal to 4 pi times 2 squared dr over dt. So 4.5 equal to 16 pi dr dt. So dr dt equal to 4.5 over 60 pi is approximate to 0.09 feet per minute. Next example is repeating a pond. A pebble is dropped into a pond, causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the distributed water changing? So in this question, we know the equation. We need to use the equation A equal to pi r squared, and the given rate is dr over dt equal to 1. So what should we do is find the dA over dt when r equal to 4. So d over dt area equal to d over dt pi r squared. So dA over dt equal to 2 pi r dr over dt, and dA over dt equal to 2 pi times 4 times 1 equal to 8 pi square feet per second. Next, 15-foot ladder is leaning up against the side of a building. The base of the ladder is pulled away from the wall of the building at a rate of 3 feet per second. How fast is the top of the ladder falling when the base is 30 feet from the wall? What is the acceleration on the top of the ladder at the same point? First, we know the base is 30 feet and a 50-foot ladder is laying up. So the L equal to 15. Use a formula like this, we know the H equal to 40. So to calculate how fast is the top of the ladder falling, we have 2b dB over dt plus 2h dh over dt equal to 2l times 2l dl over dt. So we just need to put the b and h and l in the equation. So we have 2 times 30 times 3 plus 2 times 40 dh over dt equal to 2 times 50 and times 0. So we have 180 plus 80 dh over dt equal to 0. So dh over dt equal to negative 180 over 80. So dh over dt equal to negative 2.25 feet per second. Now we need to calculate the acceleration of the top of the ladder at the same point. So we need to use the second derivative. So beta dB over dt plus h dh dt equal to L dl over dt. So b d square b over dt square plus dB over dt times dB over dt plus h d square h over dt square plus dB over dt times dB over dt equal to LD square L over dt square plus d L over dt square. Next is 30 d squared b over dt squared plus 3 times 3 plus 30 d squared b over dt squared plus negative 9 over 4 times negative 9 over 4 equal to 50 d squared a over dt squared plus 0. So we have the answer of d squared b over dt squared equal to 0 and d squared L over dt squared equal to 0. Now this is the 9 plus 40d squared h over dt squared plus 91 over 16 equal to 0. So the d squared h over dt squared is approximately to negative 0.352 feet per second squared. Next is your homework. The first homework is the radius of a circle is increasing at a rate of 4 centimeters per second. Find the rate of change of the area when r equal to centimeters and r equal to 30 centimeters. So when in this question we use the equation of a equal to pi r squared. So dA over dt equal to 2 pi r dr over dt. And we know r equal to 8 centimeters. So just put it in, and dA over dt so is equal to 8 24 pi centimeters square per minute. And this is the question we need to do the question A. We don't need to do the question B.
And then it's about the question 13. The radius of a sphere is increasing at the rate of 3 inches per minute. We only need to find the answer of A. Find the rate of change of the volume when inches and inches. So there is the solution. The basic equation of this is V equals 4 over 3 pi r3 squares. And dv dt equals 4 pi r squared and multiply with dr over dt. So we can just simplify this equation, and then we can get dv dt equals 4 pi multiply with 9 squared, which is 18.1, and then multiply with 3. We just need to replace dr dt and find dr dt's number, and we also need to find the r squared's number. So when we calculate, we can easily get dv dt equals 972 pi per inches 3 squares per minute. So this question is really easy, and then we need to find the B answer. We already get the equation that dv dt equals 4 pi and multiply with r squared and then multiply with dr dt. The value is changing by a factor of r squared. So we can get dv dt equals 4 pi plus, multiply with 36 squared multiply with 3. dv dt equals 50,552 inches cubic per minute. Then we need to solve the next question. This question is really similar to the former one. Question 15. All edges of the cube are expanding at a rate of 6 centimeters per second. How fast is the volume changing when each edge is 2 centimeters? So we can get V equals S 3 times, and then we can get dv dt equals 3s squared multiply with ds dt. This is very easy because we can get this by doing this derivative. Then we can replace them into the real number. Look, the s here is 2 centimeters. So dv dt equals 3 multiply with 2 squared multiply with ds dt, which is 6, because it writes 6 at a rate of 6 centimeters per second. So dv dt we can easily get that is 72 centimeter square per second. And then is the question 16. A question is all edges of a cube are expanding at a rate of 6 centimeters per second. So we can easily find this. And this is a very important fact. And then is how fast is the surface area changing when each edge is 2 centimeters. And this is the basic equation. A equals cosine squared. So dA dt equals 22 s ds dt, and here we can find the ds dt. The s is also given, which is 2 centimeters. So dA dt equals 12 multiplied with 2 multiplied with 6. So the final answer is very easy to find, which is 144 centimeters square per second. We cannot forget the exact number of these and the exact unit. Question 22. A construction worker pulls a 5-meter plank up the side of a building under construction by means of a rope tied to one end of the plank. Assume the opposite end of the plank follows a path perpendicular to the wall of the building as workers pull the rope at a rate of 0.15 meter per second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall of the building? This question is similar to one of the example questions, which means we need to draw pictures. And according to the picture, we can easily find that x squared plus h squared equals s squared. So here, 2x dx dt plus 2h dh dt equals 2s ds dt. We just do the derivative of here, and then we just replace each number into here. So 5 dx dt plus 0.3 with the 80.75 minus 1 squared minus 2 squared equals 0. So we can easily find out the 5 dx dt's number, and then we can just multiply, we can use this to divide 5 and then get negative 0.260 meters per second. This question is not hard. This negative means moves left, not means it do not drive, because in the math, the right means the positive and left means negative. The question 24. A boat is pulled into a dock by means of a winch 20 feet above the deck of the boat. The winch pulls in rope at a rate of 4 feet per second. So we can easily find this. Here is already give us one very important detail. And then we can use the formal method to draw the picture. And we can also get x squared plus h squared equals s squared. And just derivative them and put the number into them, because here are already write some rate. So we can get 10 dx dt equals minus 104. So just divide them by 10. Dx dt equals negative 10.4 ft per second, which means feet per second. So it means the speed of the boat is increasing as it closer to the dock. And then we need to solve the B question. 2x dx dt plus 2h dh dt equals 2s ds dt. This is the basic information that we already get. And then we place the number into it. And we can easily find out that ds dt equals negative 1.538 feet per second. This means the speed of the winch decreases as the boat approaches the dock. Then find out the answer of the question 47. Find the acceleration of the boat in exercise 24 when there is a total of 13 feet of rope out. The equation is 2x dx dt plus 2h dh dt equals 2s ds dt. And the basic information is dh dt equals 0. So we can find out that 2x dx dt plus 0 equals 2s multiplied with ds dt. So they are similar. Oh, no, so they are totally same. And then we just need to plus each of them because they are same. And we can just to replace each number into the 5 into x. So we can get the equation 5 multiplied with dx squared over dt squared and plus negative 10.4 and multiply with negative 10.4 equals 13 multiplied with 0 plus negative 4 multiplied with negative 4. So the question is very easy. We can easily find out dx squared divided by dt squared. So the answer is d squared x over dt squared is equals negative 18.432 feet per second squared. So that's all. Thank you for listening.